All right, here we are with ores and purity. So remember that this is going to kind of be like percent yield, except that it's going to kind of be in reverse. So what they're going to do here is they're going to give you the total, and you're going to have to figure out what the part is here. So if you want to know what the percent purity is of something, right? So you're going to have the actual amount of the chemical versus the total amount of the ore that is there. So remember, the ore is the chemical plus stuff, right? Stuff that's not the chemical. So the actual chemical is only going to be a part of the overall total of the ore that's there. So again, it's kind of like the last set of problems, except it's going to be a little bit backwards. It's still going to be the part over the total, except that they're going to give you the bottom part, which is the total amount of the ore. They're going to give you that, and then you're going to have to calculate that guy there, the part. So how do you know that that is the case? Well, let's read the problem. A sample of iron ore is tested for purity. So they tell you right there that it's the ore. And it says right here, it says that you've got a 30-gram sample of iron ore. So that, you can come right down here, and that is the number that's going to be in the bottom. That is your total ore. So that's iron plus other stuff, dirt and rocks and whatever else. You know, wood chips, whatever it is that you dug up with that. But the total ore sample only weighs a total of 30 grams, but only a part of that is actually going to be the grams of the iron. So you don't care about the 30 grams because it's the ore, it's the total. So what are you going to do? You're going to take the information that was given to you and you're going to work it into the unit that you want. And the unit that you want is going to be grams of iron. So you're going to be interested here in grams of the iron, and they gave you in the problem 38.2 milliliters of 0.5 molarity of this stuff here. Now, minor note here, please note that it says K2Cr2O7, but in this guy here, there is no K2. So where did it go? Well, again, potassium is one of those that is a +1, and so it's always going to be soluble. So the potassium has just been removed from the equation as a spectator ion. So we're going to ignore the potassiums out of there because they're not even in the equation. And so that's 2 +1s, and so that's going to be -2. Oh, okay, that makes a lot more sense then. So this guy here is that guy there. So don't be thrown by little things like that. This is not a limiting reagent problem, so easy breezy mac and cheesy. We are going to take this guy down here. Molarity is equal to moles over liters, so I'm going to have to take my 38.2 and turn it into 0.0382 liters. Because again, this is my real world and this is my mole world here. So 0.0382 at half a molarity is going to be 0.0191 moles of this stuff right here, which has a big old 1 in front of it. I could go to this guy here, which is the 6, so that's going to be a 6-to-1 ratio, which is going to get me 1146, like so, moles that are there. And now I want to go up to grams, and this is iron. Iron weighs 55.85 grams per mole. So when you do the math on that, you end up with about 6.4 grams of actual iron when you are done. So the actual part that you care about is 6.4 grams out of a total of 30 of the ore that they gave you that you don't have to do anything with until now. And so you end up with about a 21.3% by mass, or a 21.3% purity